My name is Stacie Wolny. I'm a GIS analyst, and I'm going to give you an introduction to the InVEST carbon model. The InVEST carbon model is very simple. In it, carbon stock is estimated as a function of land use and land cover, and changes that happen to land use and land cover over time. The model calculates carbon storage, which is the mass of carbon in a landscape at a particular point in time. It can also calculate carbon sequestration, which is the change in carbon storage in that same landscape over time. Optionally, if you want to assign a monetary value to sequestration, the model can perform valuation. The general question that this model addresses is, how do changes in land use affect carbon storage and sequestration? Some of the specific decision contexts this model can be useful for include identifying possible areas for RED credits. Places with high values of carbon storage now, or the possibility of high sequestration rates in the future, may be eligible for RED credits. Targeting payments for conservation. If a landowner has high levels of carbon storage on their land, they may receive a payment in exchange for not developing that area. And looking for overlaps with other ecosystem services. Often, areas with high carbon storage correspond with areas of high biodiversity, watershed services, and other ecosystem services that might be of interest. The way the model works is to consider 5 carbon pools. The first 4 carbon pools are related to each land use and land cover type. The first carbon pool is above ground biomass, which is the amount of living plant material above the soil. The second carbon pool is below ground biomass, which is the amount of living roots below the soil. The third carbon pool is soil carbon, which is the amount of carbon contained in the soil itself. The fourth carbon pool is dead wood, which is the amount of dead decaying plant material. Optionally, the model can consider a 5th carbon pool, harvested wood products. This is when wood is harvested and turned into houses, firewood, and other types of products that also decay and release their carbon over time. The total amount of carbon calculated by the model is the sum of all 5 of these carbon pools, and sequestration is simply the change in storage between future and current landscapes. Because this model is simple, it has several limitations. First, the carbon cycle is very simplified. It does not take into account growth rates, climate, or other dynamic factors that influence the carbon cycle. The economic valuation assumes that carbon is sequestered linearly over time, when it is often the case that the actual sequestration path is nonlinear. The model output is only as accurate as the land cover and carbon pool data that is provided as inputs, so it is worthwhile to look for high-quality input data. And finally, carbon sequestration only occurs if a land cover changes over time or wood is harvested. Changes in storage because of plant growth are not directly modeled. There are 2 required inputs to the carbon model: a land use land cover map, as shown in the image to the right, and a table of carbon pool values for above ground, below ground, soil, and dead wood, corresponding to each of the land use land cover classes in the map. Optionally, to include the 5th carbon pool, harvested wood products, spatial information about timber harvesting is required. In order to calculate sequestration, a future land use map is needed. If you want to consider the landscape for RED credits, a future RED policy map is required. To put a monetary value on sequestration, economic data is required, such as carbon price and discount rate. And finally, the model can do an uncertainty analysis if additional carbon pool data is provided. Depending on which input data you provide, the model can produce different types of output. The most basic output is a carbon storage map, like the one pictured to the right, where values are given in megagrams of carbon. If a future land cover map is provided, carbon storage will be calculated for it, as well as sequestration between the current and future maps. If a RED policy map is provided, output will include a sequestration map for that RED scenario. If economic information is provided, valuation results will be generated based on the amount of carbon sequestered. If uncertainty information is provided for the carbon pools, confidence intervals for the uncertainty analysis will be calculated. And in all cases, an HTML summary page is created containing a compilation of all of these results. In summary, the InVEST carbon model provides information on carbon storage, sequestration, and valuation to help with understanding the spatial pattern of carbon storage and the value of the landscape for carbon sequestration.